Welcome back to Simplified Chemistry. In the previous videos, I have covered the topics of relative formula mass, the mole, and the Avogadro's constant. In this video, I'm going to talk about calculating masses and moles of compounds. By the end of this video, you should be able to calculate the number of moles of any substance. You should also be able to calculate the mass of any substance if you are given the number of moles. Here is a typical question that involves calculating the number of moles. Find the number of moles of sodium chloride that are present in 3.5 grams of sodium chloride, given that the relative atomic mass of sodium is 23 and chlorine is 35.5. Before I dive into the calculations, I want to talk about the underlying principles so that we fully understand what it entails. Let's take a scenario where we have sodium chloride in a pile. We take a specific amount of salt and transfer it into a conical flask. Then we weigh that salt. There are several ways of expressing the amount of salt in the flask. We can express the amount of salt as a mass in grams normally. Another way involves using the moles. This entails counting the number of particles. It is very typical in chemistry to quantify the amount of substances using moles. For example, when we are calculating the amount of reactants and products in a reaction. 1 mole of a substance contains 6.022 times 10 to the power 23 particles. And these particles have a mass in grams, which is equivalent to the relative formula mass of the substance. I have covered the topic of the Avogadro's constant in the previous videos. Please feel free to visit my channel to check this topic out. To calculate the number of moles of any substance, we use the relationship between the moles and the mass. This is given by a general formula which states that the number of moles is equal to the mass in grams divided by the relative formula mass of a substance. I'd recommend that you try and learn this formula because this is one of the most common formulas used in chemistry calculations. The easiest way to learn this formula is to recognize that on the right hand side of the formula you have a fraction. This fraction is just a pair of masses. The given mass, which should always be on the top part of the fraction, and the relative formula mass on the bottom part of the fraction as the denominator. Here is a typical example. Find the moles of sodium chloride in 3.5 grams of sodium chloride. If you're given the mass, follow these 3 steps. Write the formula of the compound for sodium, and by writing this formula, we know that we have 1 atom of sodium and 1 atom of chlorine. Calculate the relative formula mass of the compound in step 2. The relative formula mass of sodium chloride is 23 times 1 plus 35.5 times 1, which is equal to 58.5. 23 is the relative atomic mass of sodium and 35.5 is the relative atomic mass of chlorine. We multiply each by 1 because we have 1 atom of sodium and 1 atom of chlorine in the sodium chloride formula. Step 3, you write down the equation, which states that the number of moles is equal to the given mass divided by the relative formula mass. If you're given the mass in any other unit, convert the given mass to grams before you apply it into the equation. In this example, we have 3.5 grams, so we divide 3.5 grams by 58.5, and this gives us 0.06 moles. Now let's reverse the question to create a situation where we know the number of moles, but we don't know the mass. Find the mass of 0.06 moles of sodium chloride. We know the relative atomic mass of sodium is 23 and the relative atomic mass of chlorine is 35.5. To calculate the mass, follow the same steps. Step 1, write down the formula of the compound. In this case, is sodium chloride. Step 2, find the relative formula mass of the compound. Set the formula for finding the number of moles, which is equal to the mass in grams over the relative formula mass. In this question, you can substitute the known quantities into the equation. We know the number of moles is 0.06 and we know the relative formula mass is 58.5. We can rewrite this as 0.06 divided by 1 equals to the mass over 58.5. We can rearrange the equation to get the unknown mass. We can do this by using the cross multiplication method. In this method, you multiply the numerators with the denominators on the opposite sides. This gives us an equation where mass is equal to 0.06 times 58.5, and this is equal to 3.5 grams. You can arrive at the same answer by using the mass formula, which states that the mass is equal to the number of moles times the relative formula mass. But you don't have to remember this equation as long as you understand the principles of the general formula that is highlighted and how you can rearrange the equation to work out the mass.